Welcome to Unit 10.2, Pan Balance Problems with Two Balances. Today we are going to talk about how to solve more complex pan balance problems. Here you can see that we have two pan balances. One contains a block, a coin, and some marbles. The other contains a coin and some marbles. We have to use one of these balances to help us figure out the other balance. Looking at the one on the left, I feel a little bit overwhelmed. The one on the right looks more simple to me. So, I am going to solve that one first. Since I already have one coin on the left side of that pan balance, I don't have to remove anything. It is in perfect balance. I just need to count the number of marbles on the right side to figure out how much one coin weighs. As you can see, there are 7 marbles on the right side, so one coin weighs as much as 7 marbles. Now I can solve the pan balance on the left. Because I know that one coin weighs as much as 7 marbles, I can now remove one coin from the pan balance on the left and also 7 marbles. There's one coin, and these are rows of 4, so I'm going to remove all 4 of those and then 3 of those, and I will be left with 13 marbles. This will keep the pan balance in perfect balance. What I find out at the end of this problem is that one block weighs as much as 13 marbles. Can you see how these two pan balances depend on each other to be solved? Now let's move on to a second example. Here again, you see two pan balances. Which one of them is easier to solve first? I am going to begin with the pan balance on the left this time. On this pan balance, I do not have similar objects, but I can divide the objects up using fractions. If I take half of the B-cans away, can I also take half of the ounces away from the right side? The answer is yes, because 18 is divisible by 2. When I take half away from each side, I am left with one B-can on the left and 9 ounces on the right. 18 divided by 2 is 9, so 1 B-can equals 9 ounces. Now I can solve the pan balance problem on the right. Since I know that 1 B-can weighs 9 ounces, I will use that information for the second pan balance. First, though, I notice that I have similar objects on both sides of my pan balance. So I'm going to begin by taking away as many of the similar objects, this time B-cans, away from both sides as I can. Remember that I have to keep the pan balance equal on both sides so it stays balanced. What's the largest number of B-cans that I can take from each side? Since there are only 2 B-cans on the left, I can take only 2 of the B-cans on the right away. Now I am left with 3 A cubes here and 1 B-can here. How do I use my knowledge of the weight of a B-can to figure out how much 1 A cube weighs? Clearly, 1 A cube is lighter than 1 B-can since it takes 3 A cubes to equal the weight of 1 B-can. If I take away 2/3 of the B-can and 2/3 of the A cubes, I will be left with my answer. I'm taking away 2/3 because I want to end up with just 1 A cube at the end. 2/3 of 9 is 6 because 1/3 is 3 and 3 times 2 is 6. 9 minus 6 is 3, so 1 A can equals 3 ounces. Basically what I did was 9 divided by 3, which equals 3, and that gave me my answer. Finally, let's look at a third example. Here are our two pan balances. I am going to choose to solve the pan balance on the left first. Since I have no common items on both sides and only one item on the left side, I don't need to remove anything. I can see that an empty cup weighs 8 marbles. I'm just going to make a note of that on the side. Next, I can see that I again only have one item on the left side, so I don't need to remove any objects. Since I know that an empty cup weighs 8 marbles, I am going to cross off 8 marbles from the right of the second pan balance. This takes away the weight of the cup and leaves me with just the weight of the coffee in the cup. I also need to remove the cup holding the coffee. I'm just going to draw a little line around it so we remember that it's gone. Once I do these things, I have 9 marbles left. 9 marbles equals the weight of half of the coffee. As you can see over here, we only have a half full cup of coffee. If the cup were full, the coffee inside the cup would weigh 18 marbles, since 9 is half of 18. If the cup were full, the coffee plus the cup would weigh 26 marbles, because 18 plus 8 is 26. We also need to have our answer of 8 written right there. Again, you can see how both pan balances depend on each other to help find each other's answer. Here is your practice problem for the day. 1 square weighs as much as blank marbles. 1 triangle weighs as much as blank marbles. Make sure to use both pan balances in the picture on your sheet to solve this problem.